Bird droppings, dust, chemicals, and organic matter reduce the amount of light that reaches the solar cell. The efficiency of a dirty solar panel is reduced on average by 20 to 25%. In some cases, it is reduced by half. Usually, solar modules are washed and cleaned with brushes, using a lot of water, which is expensive and not feasible in areas where clean water resources are scarce. Researchers at the Massachusetts Institute of Technology have invented a technology that cleans solar panels without water or contact with their surfaces. An electrode is used for this purpose, which moves along rails with the help of an electric drive. The electrode passes as close as possible to the plane of the solar module and electrifies the layer of dust. When the same charged particles are transferred to the surface of the module, similarly charged dust particles bounce off. The process is fully automated and occurs without human involvement. Sol Technologies announced that their first-skit PV has achieved an incredible efficiency of 31%, which is a very high performance for this type of solar cells. First-skit solar panels are a new type of solar cells that are produced on an ultra-thin plastic substrate using the method of slim printing. Compared to silicon photovoltaic cells, they are significantly thinner and have a broader light absorption spectrum. Additionally, the cost of 1 watt of power from a first-skit cell is 5 to 7 times lower than that of silicon. Moreover, they can be manufactured with relatively cheap and easily accessible materials, which can reduce production costs. Due to their flexibility, first-skit solar panels can be used in wearable devices and automobiles, and can be installed on curved surfaces such as roofs and building walls, allowing for maximum use of solar energy. New ways of using solar panels also include their use as window curtains. The Polish companies Zabka and Sola Technologies have gone even further. They have installed new price tags in their store based on the first-skit technology called dynamic price. This allows them to simultaneously change prices across their entire retail network and automatically lower the price of products that are nearing their expiration date. How to overcome limitations inherent in solar energy on Earth. What if we could place solar panels in space and transmit energy to Earth? It may sound like science fiction, but such work is already underway. The Space Solar Project of the U.S. Naval Research Laboratory is testing the ability to generate and convert energy on space satellites in low Earth orbit. A prototype of a space-based power station, the photovoltaic radio frequency antenna module, has been tested successfully as part of the experiment. The transmitting equipment, which converted solar energy through panels installed on the satellite, successfully directed electricity in the form of microwaves to Earth. The success of this experiment provides hope that in the not-too-distant future, we will have clean sources of energy available 24/7. Have you ever thought that in many cases the roofs of apartment buildings are not utilized? This space could be used in various ways, but the company SoShare presents the most effective method. They have installed solar panels on the roof of a 24-unit building in Wales. This was done as part of a pilot project funded by the government of the county of SoShare. The kit includes panels, inverters, and batteries that convert the energy generated by the solar panels into AC. The social purpose of the project is to fairly distribute the electricity generated by the solar installation among the tenants of the building. None of the 24 tenants have paid a penny for the expensive equipment. Now, solar kilowatts cover 55 to 75% of the building's electricity needs. Each of the apartments pays half as much for electricity. This is not the first solar project for the Australian company, and the challenge for their engineers was to find a solution to optimize the distribution of energy among the apartments. Not limiting themselves to established approaches, true scientists can develop more economical and environmentally friendly technologies. For example, they can find a way to capture more solar energy without increasing the area of solar panels. Inventor André Brossel set out to gather as much solar and even lunar energy as possible. The result of his work was a transparent sphere that, like a lens, focuses the solar flow onto a photovoltaic element through a dense and stable stream of light. The small-sized solar module provides power comparable to that of a large battery, capturing the brightest rays and working in low light conditions. The Beta-U motorized solar tracking system allows the photovoltaic element block to rotate on two axes. Using video cameras, the solar module is accurately positioned on the sun. The sphere can be used as ordinary solar panels to increase the energy consumption of a building and potentially as a station for charging electric vehicles. Another interesting proposal is to use this technology like windows collecting solar energy, although it may take some time to get used to the inverted view of the outside world. The team from the Eindhoven University of Technology has won the Solar Car Race World Solar Challenge 4 times in a row. When the team leader, Lex Hoefsloot, founded Lightyear in 2016, no one doubted that they would create the best solar car in the world and launch it into mass production. The first car produced by the company was the Lightyear 1, which was released in a limited series of 100 cars. However, the pinnacle of technical perfection was reached with the Zero model. The Lightyear Zero solar sedan has a lightweight, aerodynamic, spacious body with a volume of 474 liters and 4 motor wheels. The onboard battery provides a range of 300 kilometers without recharging, and the main feature of the Lightyear Zero is its solar roof made of flexible film-based photovoltaic cells with a total area of 5 square meters. According to the Lightyear team's calculations, the car can drive 11,000 kilometers per year using only free solar energy. This figure may seem insignificant, but as solar cell technology advances, we may be able to drive much further on solar energy in the future. Regarding vehicles and airplanes that run and fly on solar energy, we already know about them. But what about other types of transportation, such as trains? A group of enthusiasts from Byron Shire, Australia, converted a 2-carriage train into electric traction powered by solar energy. This is a great example of how to use resources very efficiently. Volunteers, under the guidance of experienced engineers, restored a retro train from 1949, which had been sitting in a locomotive graveyard. Now, the historic train is back in service, carrying over 100,000 passengers per year. It has a second life as the world's first eco-friendly train, with 2 electric motors running on solar energy obtained from 6.5 kilowatt solar panels on the train's roof. The onboard lithium-ion batteries are also charged during braking and while stationary. The 30 kilowatt solar batteries on the roof serve as a charging station. The train requires only 23% of the energy generated by the solar panels to operate on the route. The remaining clean energy is returned to the grid. By 2050, humanity must transition to green energy and zero carbon emission transportation. The path to a clean planet is impossible without new inventions and technologies. We will continue to keep you informed about them. Subscribe to our channel to stay up to date on the latest discoveries in science and technology.